lightning talk on simple project automation using Argparse and Make. And feel free to interrupt and ask any questions. The more interactive, particularly for lightning talks, the more they're like a discussion, or the better they are. And if you have any suggestions, and this is really what I do. This isn't, so I'm interested in hearing what other people, how they approach these kinds of problems. So until kind of last November, I was an independent consultant for several years, and I built a lot of small proof of concept projects in Python. So these would be things like to evaluate maybe some open source tool to see whether my client might want to adopt it, do performance benchmarking, do also kind of prototype product ideas and see, to get a better sense of whether it's feasible or not to implement as a full product. So those are some kinds of things I would do. And for these, basically, they're mostly implemented in Python because that's kind of my go-to language if I want to get something done quickly. And, I want to quickly iterate through scenarios in the project, try out different things. And then kind of once I've gotten to a certain point, I may be handing it off to someone else, right? And then sometimes I'm actually resuming a project, so I may put it on the side burner and then pick it up a couple months later. And I just had this happen this last weekend. I was picking up something that I had worked on in November, I guess, early November, and just trying to kind of context switch and remember what you did and why. If you leave some breadcrumbs for yourself, it's a lot easier to do that, right? And part of those breadcrumbs is if you kind of automate things, at a very high level, basic level, not anything really fancy, then kind of the code will do that for you. Any questions? Okay. So my kind of general approach that I've used on a bunch of these projects is, it isn't rocket science or anything. So Argparse is this module that's in this Python standard library for building command line interfaces. So you can have, a bunch of options and positional arguments, as we'll see, that you can pass into your program. And so if you use that, rather than say having just a couple Python functions, then you can, for the command line, quickly try different options out and try different things, right? And plus, one of the things I try to do is avoid like hard coding system paths and things like that in the scripts themselves, so that if you copy it to someone else's machine, you don't want to have it, you don't want to have it, like if it says /user/Jeff, then, and it goes to Linda, then, she can't run that script without finding all those places in the code. So the second thing I do is, once I have a collection of these scripts that I'm going to run through the command line, is I write a little make file, right? And so make is, probably most of you are familiar with it. It's this very old Unix utility that's available on every Unix-like system, like Linux and Mac, and even Windows if you use the Windows subsystem for Linux. And it's a way of kind of basically building up programs by building, it builds a dependency graph, right? And it's mostly working off of the file system, but there's kind of ways we can abuse it as like a little command processor, as we'll see. So I use that to provide higher level actions to execute. And then finally, I provide a README file, to give some additional context to get started, or other things that you may need to know that's outside of that automation. So here's some Python code that I kind of pulled out of one of my projects. And I'm not going to give the full context, but and what really matters, it just kind of shows you the flavor of these things, right? So this is, you do some imports, then you have your main body of your script, and then at the end you have this main, and this is going to use Argparse to build up these options, right? And so there's these switch options. So you can have things like here, basically this is a value, you can give it a string value, or it can be, it can have no value at all, right? There's some Boolean options as well, right? So like skip a missing detail or overwrite. Then there's a bunch of positional arguments, and these are really for passing, in my case, I'm using them for passing data data files and directories and things to this thing, so they're not hard coded in the script. And like when I'm doing machine learning, a lot of the hyperparameters and things that I might be running, those end up becoming command line options to my script that's going to do the machine learning. Then at the very end, I have like, if, basically if name equals main, then I'm going to run this main option. Any questions on that? Okay. So, and one nice thing about doing this is it basically will build you the command line documentation for free. So if I take that same code and you run the script with -s help, as you can see, it's going to show you, okay, I have these various options and positional parameters, right? And it's telling you what values they take, the positional arguments, what they mean, right? Which I had to put in that Argparse and in the various other options. So, if I come back 2 months later and want to, remember how I configured this program, it's right here, right? And someone else can just run the -s help to see real quickly. And finally, you can take this text and just copy it into your README file, right? And then it's right there as well in your documentation. So here's a make file example, and like I kind of mentioned earlier, make was really originally designed that you're building programs on the file system. So like in the old days, like you have a C program you're building, you have this thing, the executable, and it depends on the C file and it depends on the header files. And it's going to go look at the file modification dates and build a dependency tree and what it needs to rebuild. So in this case, I don't even need all that, right? In some cases, maybe you want some of that, but I don't really need the full functionality. So what you can see here is, first of all, I'm setting up some directory paths that I'm going to pass into my scripts. And I'm using this little thing, $shell, and going to the directory and printing the current directory. And so this is giving me basically absolute paths that I can pass into my scripts. So relative to where I'm running this make file, then I have that information. Then, so these are called make targets, these things with the colon after them. And these are the basically going to be my command actions. And the first one that you put in the file is going to be the default one. So if I have the make file in a given directory and I just type make, it's going to run make help. And so what I always do is help is basically kind of tell you what the other commands are, right? So then again, you get kind of easy documentation. And if you have a bunch of these, you might not remember, did I put process-ml or process ML with no dash? If you can't remember, you just type make help and then you can see it again, right? And so I have a bunch of these, and you can see like this one is actually running for the code. I'm running the my Py type checker and then PyFlakes on my code as something I might want to do after I've made a bunch of changes. So this process ML action is actually going to run that script I had, and you can see I'm passing in, these command line arguments, and it's pulling the files from the top here where I defined them. And so one nice thing about kind of having this make file wrapper is I don't have to remember I built all this configurability, but most of the time I'm only going to run one set of options. So I can just go and just run make process ML rather than typing all this out, right? And it's really quick. And last thing I'll mention on make is there's this .phony, and that's so if a target doesn't correspond to a file in the file system, this is how you tell it that. Anyway, so makes on almost every system. I don't have to write a big shell script or anything. I can just kind of abuse it like this, and then I have my command level automation. Okay, so and don't forget a README. So in this case, I like restructured text or markdown because then if you look at it, if you view the README on GitHub or GitLab, it'll kind of render it with the the bold and the larger fonts and things. But you can use plain text as well. So I include in this README, I want to always include kind of external dependencies and install instructions. And if I have a bunch of Python packages, and I'll always include in that directory, I'll include like a requirements.txt or environment.yaml for Conda to say what I need, right? That way, if I'm picking this up, oh, what versions of the libraries did it work with, then I have it there. Then the README should also talk about those commands that I had in the make file and maybe what they do if it's not obvious from the names. Sometimes it is, sometimes it's not. And then finally, points of configuration, things you might want to tweak that are not in the default setup that you might want to change, to try out different things. Okay. So if your project grows too big, there's more sophisticated tools you can use. If you really want to build a complicated command line interface, there's this library called Click, and you can build you can build interfaces like Git has, where you have commands and subcommands and all kinds of options. So it's very powerful if you need something more powerful for the command line. And there's more complicated orchestration tools depending on what you want to do. So this little make file is not enough. Then you can kind of, as your project grows, replace it with something more sophisticated, right? And so that's one way to do that. Documentation, I like Sphinx. So that's, kind of the tool used for a lot of the Python documentation. And you can take a bunch of either markdown or restructured text files. And then once you grow beyond a few, then you can kind of wrap it up together into more formal documentation. So anyway, those are my little hints on how you can kind of set up some simple automation for your project. And I hope you find that helpful. Are there any questions?
Can I have a comment instead of a question? Is that all right?
Sure. All the
One of,
better.
one of the things I was going to mention was Click, but you actually already brought it up. I mean, I assume you're using Argparse because it's already built in. There's no external library dependency of anything like that.
Right.
I personally love Click for almost everything. And you know how I heard about Click originally?
How?
PyCon. I was at a PyCon talk and Armin was about to speak and the room was packed. And I remember people I've known for a long time, George was like, he's like, oh, this is Armin's talk. And I didn't actually really have an understanding of what Armin had done. And later I realized, oh, this is the guy who did Click. And he definitely has like really like, it's a pretty cool tool.
Oh,
I think Argparse is good too, and I really use Argparse whenever I don't want to have like a single file or you don't have any kind of external dependencies, no install. It can just use everything.
yeah. And I should have maybe mentioned up front, one of my kind of, I guess, implicit requirements is I want to avoid extra libraries for the
Right.
automation.
Yeah, in
Right.
that case, then
Right.
makes a lot of sense.
And of course, again, once you grow beyond the really simple thing, then yeah, I think Click is great. And I've used it on a couple projects.
Hey, Jeff, this is Chris. I have a comment and a question. Actually, maybe it's two questions. I didn't really catch what you were talking about on your make file example around the phony thing. It seemed like it was going to be obvious, but then I realized I don't really know that.
Yeah. So
And I have a question after that.
Sure. One of the downsides to using make is it's a little obscure, right? It's got a 1970s technology, but and I'll make two comments. One is kind of with these indentations you see here. These are tabs, and you have to use tabs for make. You can't use spaces because I don't remember who it was, but the story is the guy at Bell Labs who originally wrote make thought he wanted to play around with his parser and he thought it'd be cool to have tabs. And so now, I don't know how many 50 years later, we're stuck with that. But the phony, yeah. So I think what this was is that originally make was designed so that it assumes that like, if you want to have help, that if help, it expects that target to be a file. So, I mean, a better example would be like you have, like if you have compiled code, maybe you have a.out, if you remember good old C compiler or whatever, right? So if that's your target and you're saying it depends on some header file and some C file, and here's the C compiler you run or whatever. So it knows that, okay, if a.out doesn't exist, this is the rule I use to do it, right? So with the phony, it's basically saying that's a phony target. So
Mm.
I think they kind of shoehorn this into the grammar after the fact. And so if you put a dependency on phony, so like I can't actually see it on my screen because the videos are blocking it, but
Oh.
hopefully you can see. Do you see something after phony on your screen?
Yeah, check,
Okay.
help, test downloader, that kind
Okay,
of stuff. Yeah.
right. So those are all the targets that are not real files. So if I had a target that was a real file, so, maybe one of these steps created a file and so then that depended on something else. So that file doesn't need to go under phony. So if it doesn't generate a file in the file system, then you need to put the target name there.
Oh.
Yeah.
Hmm. I did not know that. Okay.
Yeah, and it's that, I mean, I guess the downside to this stuff is, some of the stuff's a little obscure, right? And I mean, you could also write a Python script to do the same thing, all this stuff here, right? It's just probably going to be, 100 lines of code and as opposed to, 20 lines of code or whatever, right?
And make files are
Yeah.
very standard. A lot of
Yeah.
things like other
Right.
languages have rake and things from.
Right.
Yeah, if I were doing
Right.
a lot of C compilation, this would make sense because my C targets, like when compiling Python code, all the C targets for the Python executable, for example, would exist. And I would go look at the timestamp and say, oh,
Mhm.
is that timestamp new or older than what I'm compiling now? Oh, that means I do have to change it, and it makes it efficient on what I'm compiling, so I don't have to compile everything, but just the things that need it.
Oh. Awesome. And so my second thing is actually, maybe it's a question for the group, but I use make files in a CI and it kicks off a bunch of testing. And I have this one scenario where all the tests are passing, but the test job is timing out because it's not returning something. And if there's any hints that someone might have on things I can try to kind of figure out what all the running processes are as part of this, without just, I guess I could write another script, please hit me up in chat. Because it's a current kind of challenge. I haven't hit on the solution yet.
Oh, I guess we'll leave it to the audience. I don't know.
Magic of the crowd. Thanks.
Jeff,
Yeah.
one comment. You mentioned that if you wanted to do argument parsing like Git does with like subcommands that you needed to use click, just to point the information that you can also do that with Argparse.
Okay. That's probably, I think I remember it has some kind of subcommand, but
Yes.
I think the click stuff is more powerful, but I haven't researched it lately. But when I was looking at building some complicated thing, I found that click was easier to use or handled more cases than the Python one. But I think you're right that the basic Argparse does have at least subcommands. Oh, the other thing that's really cool about click, maybe it also exists for Argparse, I don't know, is that so if you have this big complicated tool that has all these command line options and subcommands and all, there's a plugins for Sphinx that will go through and all that and automatically generate the documentation for you. So like when, I don't know if I gave a talk a couple years ago on this thing I built called data workspaces, and all the command line documentation is automatically generated from that. And there probably is something like that for Argparse too. Anything else? Okay, well, anyway, thanks a lot. Hope you enjoyed that. So
Is there
now
an easy way to distinguish tabs from spaces?
well, okay. So the main thing I would say, I mean, some editors will show it differently. And usually kind of if you go into the thing in an editor and basically move your right arrow to kind of go forward. If it doesn't go one step at a time, but jumps immediately to where the line begins, so instead of going like this, it jumps immediately to here, that means it's a tab. So that's one way. And usually there's like, I know you can configure like VI and Emacs, and probably like, if whoever that was could.
I got it.
Anyway, but usually I think the more modern things, probably like VS Code and all, well, if you edit this, they'll have a mode where they'll automatically insert the tabs for you. So. Any other questions? Great. Well, thanks a lot. I'm going to now turn it over to Linda. Linda's a director of data science engineering at Cisco, and she's going to talk to us about time series anomaly detection.
Let's start. Hi, Linda. If you want to ask questions, just do it interactively when I'm going through the slide. So that's much easier for me to answer with the context. So through my work, I'm dealing with anomaly detection on different type of data, from metric data and log data, events data. So this is my focus area, basically. But if you look around in your life, you will see, for example, your stock has time. If you remove the time, the stock graph to you doesn't make any sense to you. This is a COVID until January 22nd, California new cases. You can see based on time how many cases are showing up every month or quarter. And if you use a iPhone health, you go in, you will see the days you walk, how many, what's the energy burned, and things like that. So why we are looking at it. So the first thing is this is, let me talk about this graph on the left-hand side. So this one is GameStop. Probably most of you have heard about GameStop, what happened in January 2021. So if you look at the first red rectangle here, so this peak, why this is happening? So if you are interested in stock trading, the peak happened because of a Reddit subreddit. It's called Wall Street Bet. So a whole bunch of small investors want to bet against Wall Street. So they keep on buying the GameStop stock, the stock at any price. So, and then because the hedge fund is betting against it, so because of the hedge fund the option is expiring, so they have to buy shares to cover them. So they actually went from about $4 the day, about 25 days before the peak, so to push the stock to over $300. So that they bet against Wall Street. So actually one of the mutual funds lost billions of dollars just for that option itself. So the drop afterwards is because people start to cash in, selling their stock. So you see a drop here. So the second one, Wall Street doesn't even know why. The second one picks up, and then from that on, it's keeping way over the $4. It's about over $100, but just changing daily or monthly based on that. Okay, so that's interesting on whoever is trading that stock. You probably want to know why your stock suddenly go up or down. So the other one, we know it very well, or we'll have to deal with it daily, is COVID. The new COVID case. So if you see the peak here, this is a 2020 December. So around that time, leading towards December, which is Thanksgiving, people get together, and then holidays, people get together. So that time is about Delta, right? The Delta variant. So you see the not peak, but little bump from last a year ago. So this is from December to January this year. You can see this big increase on the new cases because of Omicron. So you can see that from these changes, you will see, oh, that's anomaly. What's anomaly? What's causing that? Why is not like the wave before that? Is because, okay, the event is Omicron variants to cause that peak. So for the right hand side, I guess, on your screen. So in that, this Sunday, maybe it's like me. Sunday, I'm taking time off. I'm not walking. I'm just staying at home, eating. So that's why there's no steps recorded. Maybe I just didn't bring my cell phone or didn't wear my watch. That's why it's not recorded. So that's why you want to know when you look at your health status, why you're not burning energy that day. So this anomaly will tell you something is going on. Okay. In general, you have several use cases, what I call applying the anomaly detection. So one thing you probably hear a lot is about fraud detection. So in financial industry, credit card transaction, right? So when they see the credit card transaction, what they do is they look at your previous purchasing behavior, where you shop, how much you shop, those kind of information will come in, and then to detect whether they will allow the credit card transaction to go through. Okay, so it's more sophisticated than that, and because they will take your location, sometimes will also record your computer data, so to make sure that this is not a fraud. Okay, insurance also using that for fraud detection. If you have a lot of minor car accidents, why is that you did that on purpose or you colluded with someone else? So that will help them to reduce their cost, right? So you will hear that fraud detection a lot in normal life scenario. And then the other one is more about in the middle, we're talking about the failure detection. So mostly I have seen it in IoT or in IT, like if you deploy the services or your application. So for sensor, you want to know if the sensor is not working. The sensor can be the temperature, can be the moisture. So those kind of things, or machinery. So on the current production line, all of the new modern production line have all kinds of different sensors, especially for safety, right? If that has a failure, you might cause an accident or death in certain case. So you want to know that whether it's something is going wrong in that situation. And for IT, I mentioned that it's more on computer infrastructure, whether you compute your server, your networking, your disk drive, to detect whether that's a failure over there, and of course software. So when you detect the anomaly, it's good, it's something not working. You probably want to find out why it's not working. So you will go into root cause analysis. So the failure point or change point you detected, you will use that to help you to see what caused the problem. Okay. And then in machine learning, a lot of times we collect data. A lot of data points we receive has outliers that will impact the entire data distribution. So you can use that to detect the outlier and then remove the outlier. So your data will be smoother because of you applying that outlier detection. Okay, I'm sure there are other use cases, but these are the ones that I have seen a lot. So before I go into algorithms and things like that, I want to just make sure everyone is on the same page on what's the terminology we use in this field. So you might hear people talking about univariate versus multivariate. Univariate, just a single metric. Okay, your CPU. You measure your CPU for an hour. You have the percentages, right, and the time. So that by itself, or the value itself, is because it's only CPU. Since it's a time series, we assume you will have a time series, the time column. So the value itself is 1. So one metric. So in this case, we call it univariate. Versus you look at a computer, you capture CPU memory, disk I/O, networking. So if you capture 4 different metrics, so that's together we call it multivariate. Okay, so all of this data you collected, it might have trend. The trend could be going up, could be going down, right? So you deploy a new service on Amazon, for example, you will did some enhancement, but you might introduce latency. So suddenly the latency is going up, right? Or you improve your performance, so your latency is going down. So it could be up or down. Seasonality is about, in the pattern, you can think about like you join a wave, right? So seasonality, for example, we all know Black Friday. So the shopping season for the shopping side, Black Friday. So you will expect every year around that time, the traffic goes up. Okay, so that kind of could be yearly, could be quarterly, monthly, daily, weekly, depending on what type of data you are collecting or what kind of system you are monitoring. And the other one is called drift. So drift is more like you're running at a certain baseline, suddenly it's moving up or down because certain condition changes. I have slides after this will show you graphically what it meant. So change point is between the, for example, is drifting up. So that 2 points is called change points. Okay. And the other one is anomaly. Sometimes you heard outlier. Okay. So in the academic world, that's the same. It's interchangeable. In my daily life, they are different. Anomaly means something went wrong. I got to take some action to correct that. Okay. Outlier means something go wrong, but I have to monitor a little bit more to decide whether I need to do something. Okay. But in more research academic world, these 2 words are interchangeable. The last one is stationary. So stationary time series is the data you collected. It does not have any trend or seasonality in it. Okay, so why you need to know all of this is because the algorithm will apply to different data shape. You need to know whether your time series data has this kind of characteristics. So this is a more of a graphic way talking about the same thing, just the concept. So this is a univariate. You have one matrix coming in, and you can see this is just a noise going up and down. Okay, and versus the lower part, multivariate. This is a CPU, memory, disk, and a network I/O traffic latency. So those are the 4 different metrics. So I will call it multivariate. This one is more of, this is the raw data I collected, right? It's going like that. But if you decompose it, means you want to find out whether they have trend. So there are statistical methods you can call, and it will decompose the raw data for you and show you, in this case, has going up, the trend. And then you can clearly see the seasonality now because the trend is removed. So you can see the pure the wave more going up and down regularly. The second one, the drift, I mentioned drift. So what's drift is when you collect some, for example, this is some new service you are running, and suddenly because the service is serving a lot of caller or the application, so the latency is way going up. Okay, so from here and up, you can see the baseline change significantly. So this is a drifting upward. And then this point is called change point because at that point, it started a new baseline. So let's say that this same service, not many, the caller reduced. So you only need to serve, instead of serving 1,000 callers, so now you only have 2 to serve. So then you started to drift down on the latency, right? So less latency. And this point is the other change point, okay? So this is just a side-by-side view on what's stationary.
No cars inside.
Yes.
Look.
Versus non-stationary. So stationary data is look like this as there's no pattern, it's just noise, but the base is still almost like in the, if I can draw a line, the mean is right there, okay? Versus this one, you can see is going up, right? So it has trend in that, okay? So okay, so this is a that graph I take it up, and so the red line in the middle is the mean, because this data does not have a seasonality, does not have trend. So in this type of data, you can use Gaussian normal distribution type of algorithm to calculate that. So you can calculate the mean, and then you have a standard deviation, right? How much you can tolerate this. And outside of that, there are the what you call outlier or anomaly. So the red dots here are the anomaly for this metrics. So I talk a lot about everything. You look at it as, wow, everything is number. It's not, I hope that's the truth, that it's not. So this is a Unix time, right? And then these are the value I collected for that each corresponding, I think is every minute, collecting this count, okay? So, but if you look at log files, it's time series data too, okay? Because it has time, it tells you what's going on. You just need to process further in order to convert it to a metric format, so you can call the algorithms to detect anomaly. I just want to point out the anomaly detection is not just the numerical value, okay? So to approach how you detect anomalies, there are two ways or two different approaches. So one is just called anomaly detection. It's just the name is not very clear. The other one is forecasting. Okay, so anomaly detection means the data points is different. It's deviating from what you're expecting. Right, means you have a, for the simple ones, you have a mean and standard deviation, you are deviating from that. Or more sophisticated ones, you are deviating from the moving average, for example, right? So that's what you say, oh, this shouldn't happen. Why is it happening? Okay, so that's more of using the anomaly detection method algorithms to detect that, versus I know, for example, in IoT, okay? So in IoT, your sensor is should behave the same way, okay? So, but if you use the forecasting method to detect whether the sensor is going to go out, is going to malfunction. So you probably want to consider using forecasting type of method, because you know what's right and what's versus what's wrong. Okay, so you can do predictive maintenance before the sensor goes out. You can replace it. Okay, so that's the two different approaches to detect anomaly. So now I'm just these three libraries are the frequently used, at least in my field, I guess. So Scikit-learn itself has about 5 outlier detection algorithms included. You can just install and use that. And then the other 2 are more specialized. PYOD is a library, is a framework just to for anomaly detection. It does not have other algorithms, general algorithms for machine learning. So PyCaret actually is built on top of PYOD. I will show you later with a code example. So anomaly detection, I pick isolation forest. So the reason I picked this is one of the earliest anomaly detection algorithm created by Tony Liu from when he was working on his PhD. So the way to do it is pretty simple. So if you have the time series data, and then you don't know which one is anomaly, right? So you cluster them. So after you cluster them, then you use a binary search to divide. So if you see the first line here, the red line at the bottom, so you basically slice the data you already clustered and then build a binary tree. So it's about the distance about the red dot from the cluster, the main cluster point. Okay, so that's how you build the first one. Then you slice again, that's the green line. So you slice again and then calculate still using the distance. Then you will find this red dot on this side, and then of course there's 2 blue dots also in it. So you just imagine you will recursively doing that, building the binary trees. So eventually, by recursively doing that, you will find this 4 anomaly points. That's how this isolation forest work on the high level. So if you use Scikit-learn, it has this isolation forest function. Nothing special until you look at the return. Okay, so when you look at the return, strangely in Scikit-learn isolation forest, when it is not anomaly, that data point, it actually shows as 1. So which is not very standard. So usually we will replace it the 1 to 0, and the -1 actually is that point is anomaly. So we'll replace with 1. Okay, so why it's important? Because when you select an algorithm, you will run F1, run the evaluation on your algorithm. So in that case, you want to replace this before you run the algorithm to calculate precision F1 scores and accuracy. So that's one thing I want to call out. So same thing, I want to call PYOD. So you can see everything else looks the same, but the missing 2 lines is I don't need to replace the value anymore, because PYOD is created for time series anomaly detection. So inside that library, they already replaced the number to change it to 0 and 1 to indicate whether there is anomaly. So you don't need to do that. So you save 2 lines of code. So PyCaret also has isolation forest. So but if you look at it, it completely the code itself is very different from when you use Scikit-learn or PYOD. They build a completely different libraries than Scikit-learn. So if you use PyCaret, you are committed. It's harder for you to change your code if you don't like the library, for example, somehow. So the way to call, in order to call isolation forest, you have to set it up, to create a model, assign the model, then use the predict model. So it's not, it seriously is a commitment, right? So if you decided to use PyCaret, your code will be totally different from your normal scikit-learn type of code. It is just a lot of commitment for you. Okay, so if you run the PyCaret, just run the models is one of their function call. So it will show you all of these algorithms listed here. It is built on top of a PYOD. Okay, so they're just a wrapper on top of it. So what's good about PyCaret? I'm not dinging them. What's good about it? Supposedly, it has auto ML, so you will do hyperparameter tuning for you. Okay, so you might save the time on using PyCaret. Okay, so the other side of the approach is to use the forecasting. So forecasting has different frameworks too. It's more fun. So it has, you can use the statistical method. Okay, you can use ARIMA, auto ARIMA, whole bunch of statistical method. The framework is called stats model. Okay, you can import that. Or you want to go more deep learning. So PyTorch, TensorFlow, both has LSTM, RNN, you can use that. And versus, I have to mention this one is decomposable model. The Facebook has this Profit. Profit is Facebook build it for themselves to analyze Facebook usage, okay? So just a quick explanation of ARIMA. So ARIMA is used to predict, right, to forecast future. So if you can see it when you call the ARIMA, the red line here is forecasting the 1, 2, 6 future data points. You can see that the closest one, the upper limit and the lower limit is closer because it's more precise, more confident on predicting that. The further away from the time-wise, right, then you can see the upper bound and the lower bound is much bigger, which means the error is pretty big. The gap is pretty big, okay? So then you ask, well, how would this to do with outlier? So when we do outlier detection is using the forecast plus the upper bound and lower bound. If any point, the real data point show up at this time, if it show up outside of the upper bound or lower than the lower bound, then that's outlier. Okay, this is how we use it to detect outliers. A quick way explanation. This is a very simplified way to explain LSTM. This is neural network, right? So the example I took is from one of the very good YouTube explanation. I have the link here. You can go on YouTube to watch that video. It's really good explanation. So let's say I have 9 days worth of revenue. This is daily. Day one, I sold $110, right? Day 2, day 3. So how LSTM works is I want to look back 3 days, okay? So I look back, started from the first 3 number. So this 146 here is basically your Y label. with this 3 days of data, you are predicting Y. And then with shifting to the next one from 125 to 146, I'm labeling 158. So that's your label value. So you use the 9 data points to build your X and Y. Y is your label, or I use this X, I can predict this Y. Okay. So once you go through all 9 data points, so the last one is 187, 198, 210. So if you run through the algorithm, the PyTorch or TensorFlow, the predicted value is 222. Okay. So how do you detect? It's exactly if your real value, that day, the 11th day, the 10th day, I actually only sold $22. So this one is way out of the error bound of the predicted value. So that will be an outlier. Okay, this is how you use LSTM, more deep learning method to detect the outlier. This is a profit. So profit, this chart is from Facebook. So profit specifically because it's built for Facebook. So if you know your data has really strong seasonality, for example, for Facebook data, it has weekly, yearly, has trend change, right? So because of this algorithm, this series of developed for themselves, so it worked really well for any data that has really strong seasonality in either daily, weekly, quarterly, yearly. So if you want, and in addition to that, you need a lot of data points, okay, to use profit, okay. But the thing is, if you already know that, you probably want to use other algorithm I don't see anyone has this strong of a data set and this much of a data to play with. So the other part of this is more about deployment, right? So when you try to pick your algorithm, one thing is how you deploy, if you use the outlier detection to detect real-time data, what I call it streaming data. Okay, so in that case, for example, network security. Okay, so you are trying to detect whether something is abnormal on your network, trying to attack your network. In that case, the CPU memory latency is very important for you, right? So do you have enough resources to run it, and how fast can you run, right? It's very time sensitive. So you when you pick an algorithm, you need to measure the CPU memory latency if you have a streaming requirement. Okay, so for things like on demand, basically this is for someone sitting there, have a graph, graphic user interface or command line. Someone will click or type in detect outlier, for example. In that case, as long as you respond to the user fast enough, right? Then you don't have a scalability problem because it's one at a time. It's more manual. Okay, so latency is your consideration. Okay, and then if your how you deploy is batch. Okay, so then you need to look at efficiency, right? My batch, do I run it every 10 hours, end of the day? When do I run it? And how much of resources I'm using? You want to minimize that. And then, because in my world, everything is running on the cloud. So the CPU memory, it really costs, it's our cost to run the application. So we're very conscious about the usage of those resources. So these 3 things will impact you when you evaluate those outlier detection or the anomaly detection algorithms. So any questions?
Hi, thank you. This is Han Sang. Thank you very much for your presentation. I very enjoyed your presentation. I have a question about the slides on a question on the forecasting with the LSTM.
Mhm.
So here, so we said that 22 value is kind of anomaly because
Mhm.
this kind of deviated from the predicted one. Do we have any kind of degree at which actual data is kind of how much is actually deviated? For example, this is a kind of the machine interpretation. So suppose that if I get a real value is 200 versus the 190, how can you
Mhm.
determine whether this is a kind of the outlier or not? Do we have
Okay.
kind of
Yeah, there is. So when you run LSTM, when you give you the predicted value, you also give you error rate. Okay, so you need depending on your application area, how much of a basically think about that as a deviation, how much of a deviation you can tolerate. Okay, so that's where when you run it, it will give you the error rate. That's where you can set how much of a boundary you can tolerate. So once you set it, outside of the boundary is outlier. That's how you use LSTM for outlier detection.
Okay, thank you so much. Another question. So this is a kind of univariate data. What about the multivariate data? Can you still use this approach with multivariate data?
Yes, you can use that, right? But my experience is LSTM, because of its neural network deep learning, it's pretty slow. I haven't tried it with GPU. Okay, so I do have a disclaimer there. So, but on my Mac, it's pretty slow compared to other algorithms I'm running.
Thank you so much. By the way, is that presentation will be available?
I think so. Yeah.
Okay, thank you. Where can I get maybe link to the presentations? Maybe organizer, maybe
Yeah,
we can
organizer,
organize.
I know.
So we'll put a link in the chat on Meetup. And maybe when we update the website, we'll put it there as well.
Yeah, thank you.
Yeah, so just to go through that, I don't know what kind of data you are looking at. If you start a brand new project, probably you want to look at PYOD or Scikit-learn, right? So use that. At least you need to detect. Okay, before you start any project, if it's a time series type of project, first of all, you need to know what's your data distribution. Okay, so if your data just having noise, not having seasonality or trend, I highly recommend using more statistical method. Okay, why? Because CPU memory-wise, it's much faster, right? Because it doesn't need to do the extra stuff. Okay, so so if you have you just start the project, you need to collect data and then just use the decompose method to decompose your the distribution to see whether you have trend, whether you have seasonality. You have none of those, then just use simple algorithm. It's easier for you to explain to your customer, because at the end of the day, I have to explain to customer. So the simple one should be the one you start.
Okay, thank you so much. Yeah.
Sure.
Linda, could you give us some examples where these methods were successful and other examples where they were not successful?
So in general, if you okay, because we try so many of them. If you just started, okay, like what I said, if you have done the decompose, decompose is a function call. If you call the decompose and know your data distribution, okay, has trend, or let's say your data has trend as seasonality, Okay, so I would highly recommend to start with isolation forest. Okay, first of all, it's included in all 3 libraries. Okay, second thing is because this algorithm was created 2007, 2008, a long time ago. So it's been optimized and used and debugged by so many years. So it's very efficient. So we found for large volume of data, isolation forest is something you want to start with. And the other thing good about this is it gives you the scores. So you detect multiple, right? Let's say, so it would give you a score how confident it is to say that's an anomaly. So that is the one I would recommend you to start with. And if you know you have multivariate, for example, multiple metrics you want to detect anomaly. So same thing, isolation forest, LLF, local outlier factor, also part of the library. So you can use this tool and to see the F1 score. So when you see the F1 score, when I see F1 score, what I mean, if your F1 score is more than 0.5, you are on the right track, right? With hyperparameter tuning, you probably can get more, get better, okay? So those 2 I would recommend you to start with. Did I answer your question?
Thank you, yes.
Okay.
Is there any a kind of follow-up questions? Is there any kind of method for kind of determining whether the data is this kind of has a seasonality or not?
Yeah. So there you can look into the stats model has it. Okay. I think Scikit-learn has it. I'm not so sure.
Yeah.
I know there's a function called decompose.
I see.
I don't
Okay.
remember which one it belongs to anymore.
Okay.
But yeah, there are existing methods. You don't need to write your own code.
Okay.
Yeah, you need
All
to
right.
call the function.
Okay, thank you.
I have a question.
Mhm.
I have seen some systems compute a baseline like 24 hours or 5 days or 7-day baseline, and then use some standard deviation against that baseline to identify the outliers.
Yeah.
How do you compute those baselines?
So if, since you mentioned standard deviation, so for those kind of systems, they're actually just using the basic Gaussian normal distribution. So basically you are assuming all of your data has noise. Okay, so you are building a bell curve. If you are drawing in the air, it's a bell curve means most of the time everything runs fine. Only very few on the outliers that's your anomaly. Okay, so if you have that kind of data, just have noise. So how they calculate the baseline is they will take, for example, 5 days of average, like a mean. Okay, and then when you calculate the mean, you will calculate the standard deviation. Okay, and then depending on the bell shape is steeper or flatter. So means you want 2 standard deviation away, 5 standard deviation away, or 10. So however your bell shape distribution is, then outside of that, that's the outlier. And that is not a bad method because that's really, really fast. And the bad thing about it is you have to be very, very sure, right? If your data has seasonality, like the wave kind of data in it, mean, if you calculate mean out of that, that's meaningless.
Actually, that's not what I meant.
Yeah.
So maybe I shouldn't have used the word standard deviation then. Like for example, a parameter, starts low in the morning and goes up during the middle of the day, and again it comes down, right?
Yeah.
So that variation throughout the day, you want to observe, let's say over the last 1 month.
Yeah.
And then you compute the baseline, and then you compare against that on a new day.
Okay, yeah, that's my world. Yes, Yeah, so in that case, you want to use, so how do you calculate the baseline? So that actually there's no such thing called baseline, right? So what you can do, there are multiple different algorithms, like I mentioned, the isolation force can handle it. And there are other, like ARIMA. So one of the ARIMA I did not mention is ARIMA, seasonality ARIMA. Okay, so you will account for your seasonality, like a day, starting of the day, maybe slow. Let's say you have a bank website, right? 8 o'clock, the banker started to work, so they all log in, and lunchtime, they close the door, so there's no activity, right? Afternoon picks up again, then 5 o'clock is flattened out again. Okay, so you will have this seasonality going on. So in that case, you are there are multiple different methods. One method is to calculate like an ARIMA. You have a moving average, right? That's your baseline. Okay, whether it's up or down, still you have moving average. So the if you minus that, that's only the residue. So when you look at the residue, if the residue is really, really big, right, outside of your moving range, that's how you detect the outliers or anomaly. So there are many, long story short, that the libraries I mentioned, like a PYOD, or PyCaret, the same thing, can handle that.
Hi, Linda. I have a question.
Mm-hmm.
Hi. First of all, thank you for presenting on this topic. I really enjoy your talk. I actually have two questions. My first one is, aside from isolation forest, do you have any other go-to algorithms, either in Scikit-learn or PYOD, that's your go-to for detecting anomaly? My second question is, once you find these, I guess, outliers, what are your usual steps when it comes to dealing with them?
Okay, yeah. So there is another one in PYOD. It's called histogram-based outlier score, I think. So that one I found it very, very accurate when you are detecting more like a, I use the CPU memory and the disk and networking, the latency, okay? So if you have this multivariate type of data input, you're trying to detect whether there's an anomaly, okay? So this HBase is really, really fast and very accurate. So if I see any data like that, more related, the metrics are more related, I will try that first. Okay. So once it detect anomaly, what I'm going to do is to take that where the time, because this is time, right? So let's say 3 p.m. is where the anomaly is detected. Then I would use that in conjunction with in my world is log files. Go to the log files to find the root cause.
Okay.
Okay. You can also correlate that, right? So for example, if you have additional data on which application call that service, that service has the anomaly, right? So you can also traverse up the tree. I have a graph actually. Have to traverse up to find the app if it's a shared services, right? Like let's say login is a shared service by multiple web applications. So if the logging is slow, the service is slow, so all of these applications got impacted, right? So you can, if you traverse the graph and find all of the impacted applications, then you can generate correct alerts on, hey, not just this service is slow, you're impacting, let's say 5 applications, right? So that it has different usage depending on what kind of application you are using.
Gotcha. Thank you. Appreciate it.
More questions?
Yeah, I got a question for Linda.
Mm-hmm.
I was trying to figure out which, in our language, there's a lot of good built-in detrending algorithms. in Python, I don't know which ones do you use. I posted the links to statsmodels.tsa for time series analysis.
Yeah, so there, depending on the library, for example, Facebook Profit has an R implementation. It has R and a Python implementation, but in my work life, it's Python only. So I'm not that familiar with R.
No, I'm right. I'm asking how in Python how we do it. I'm compared to R. I'm surprised how primitive the Python functions are, because in R, there's a function that will give you the weekly, the trend, the seasonal, and the monthly and the daily components. Mm-hmm. But I can't find any equivalent in Python. You have to cobble it together from like 5 different functions. It looks really nasty. There must be a function out there in, completely open source based libraries like
so the first place I will go is stats model. It does have a Python implementation.
But it doesn't. I just posted the links to it. It doesn't. It's really nasty. It doesn't give you the seasonal, the weekly, and the daily. It only gives you.
Okay. Yeah. So we have.
Mm-hmm.
Go ahead.
You're gonna have to build them. First you have to do autocorrelation and find out the periodicity of all of your components, and then you're gonna have to build an additive or multiplicative model and subtract that. And I don't understand why it's so manual.
So Python and R doesn't have a one-to-one match on that. So one thing you would use is, I think in Scikit-learn, it has, I think the decomposes from them, which will separate the seasonality. And we also use like a Fourier transformation to detect the seasonality. So we use that to analyze our data on the seasonality, whether like we detect 8 hours seasonality, 4 hours seasonality, that has it too. So depending on what you want to use.
Yeah, Fourier transform is overkill compared to autocorrelation. You can take a guess at the periods, and the autocorrelation will show a spike.
Yeah, like what you have already mentioned, Python doesn't have the one-to-one function matching yet.
Yeah, I mean, to be honest, looking at the Python libraries, it's actually really nasty. I just wouldn't do this in Python. I'd do this in R. That part.
Okay, so there's, depending on what you want to do, right? If you're analyzing data, right? You have a new project, you don't know what the data look like. I give you a whole bunch of metrics, and then if you use R, it's faster for you to detect what kind of data distribution you are dealing with. Yeah, go ahead using R. But a lot of times what I found is afterwards, if we don't know, so in my world, it's unsupervised machine learning. I don't have the luxury to find out the data distribution ahead of time, okay? Because for example, if we monitor a customer's own application, so there's no way ahead of time I would know how the application would behave. Right. So at the runtime, I will have to pick the unsupervised learning to do the outlier detection. Okay. So in that case, all of the statistical type of algorithm or method does not work in my world because we don't know.
Well, autocorrelation will always show a spike if you get the right period. You just have to guess it's the period, minutes, hours, days.
Yeah,
weeks.
I can't guess.
You manually brute force and step the thing and look for spikes.
Yeah. So when you so for example, one of my customers, they have 2,000 services, right? Applications. So each application has hundreds of services, and that being because it's on cloud, so different teams update and deploy their service at different times, and the service itself we don't know when the new release, whether it's improving or introducing more delays, or the entire behavior changes, right? So in that case, I cannot guess was this 1 minute, 4 minutes, 4 hours, right? So we're using, that's what I'm saying is we're using unsupervised learning to do it. Yeah.
Yeah. I just found the name of the function that R uses, seasonal trend decomposition using Lois, STL, and that's implemented.
STL, yeah.
Yeah, it's implemented in Python as well.
STL. Yeah, we use that.
Yeah, sure. Well, thanks very much for the talk.
Sure.
A few more coming in.
This is Chris. I have a question, Linda. Thank you so much for the talk. There's a lot of complexity here. I'm wondering if you could talk briefly about, for your business users or your customers, how do you go about boiling this down in a meaningful way?
So you mean how to explain to the customer on our models, or how we handle customers' data?
Probably the former. It's more about people want to know kind of what you did, but obviously it'd be very easy to go off the deep end and drown them in things that suddenly they're lost. But so you're trying to balance giving them kind of enough stuff so they know, like, oh, you've really looked at this, and I understand kind of where your my trust in you is coming from, but also not spending half an hour, because the talk's perfect for this audience. I can imagine a business user would be lost after like 2 minutes,
So actually that happened to me before. The customer want to know what do we do when we say this is ML driven or ML ops, right? So the thing is for us is we when you look at all of the machine learning algorithms, first of all, of course, to me, is performance is important since we're paying Amazon for the CPUs, right? But another aspect of it is what we call explainable AI, right? How you explain this black box to DevOps, because my users are DevOps and SRE. When the thing broken down, we'll give them an alert. Is DevOps SRE, right? How do they trust you? Why do you think it's alert, right? So explain to me how you generate alerts. Okay, so in that case, that's why I was mentioning in part of the talk when I say isolation forest, you want to pick some algorithms that's well known and is simple. Okay, so because last time I was talking to one of the customers, and they basically have a committee. You have to explain to their committee how you generate outliers, how you're not how line by line how it works, because there are IP issues, but they want to know from high level how the algorithm work, and they want to feel comfortable on the theory we based on is very simple and not something we do is funny when we do outlier detection. So when we pick it, is basically, to summarize this, first thing is we need to look at how well you perform, right, in terms of CPU memory. Second thing is this algorithm simpler or harder? If I gain 0.01 on F1 score, but I have to pick a really hard algorithm like LSTM, it's very hard to explain to customer, right? You will get DevOps go rolling their eyes.
Got it. Thank you.
Yeah.
Some of the modern metrics systems, I think they support something called exemplars, right? So for a given metric data point, you can also kind of point out what some examples that contributed to that. I think that might be helpful to create exemplars for outliers explicitly.
For for me, we in my line, because the code, the metrics we collected, we have no prior knowledge about it. Okay, and yeah, one of the customers is telling me, yeah, I'm going to add 200 more services next quarter. I go, new? Yeah, new. Okay. But when the business is really big, right? Global, for example, global 50 top 10 financial banking customers, they are my customers, right? Just imagine their line of business, how many of applications out there, right? So they were telling me that they are adding, even the IT guys doesn't know what are the new business applications adding to Amazon every day, right? So they can predict, they cannot even tell me ahead of time, oh, this application will have 10 users or 20,000 users, right? So you become a problem to them. They couldn't even do it manually. So that's why they want to have an automated way, at least give them some alert. Then they can go in and say, hey, what happened? Right? So that's a part of it I didn't mention tonight is how do you retrain, right? When do you decide to retrain? Because in Amazon, in any cloud world, GCP included, so the services will, especially the common services developed by a common group, they release not in line with the application release, right? So in that case, so the new common service deployed, suddenly the application slows down. Suddenly the application cannot log in anymore. You have database timeout, right? I've seen a lot of those things. Oh, something happened. I don't know why my application suddenly slowed down. Oh, go check your versioning. They compare the versioning. Oh, there are new services deployed. Okay, so they will trigger a rollback, right, for the DevOps, right? So those kind of things, yeah, it just we have to use this way to the unsupervised machine learning to monitor. We couldn't even anticipate what the service look like, what the data distribution look like.
Okay.
Hey Linda, this is Rakesh. I'm very new to this, so I have a quick question here. By the way, amazing talk here. So is there any scenario that you saw that your users are saying, hey, you generated these alerts, but I want a control from my side to say this is not an alert. So in the future, if there is some scenario like this, don't generate an alert. Is there any such control the users are asking to you guys?
Yeah, yeah. So that's the part of you for all of the algorithm, you have the hyperparameters, right? Since the users are more DevOps and SREs, so we never expose that. It's just what we call sensitivity. So you want it to be very a little bit alert, outlier. A little bit higher than the tolerable deviation, then you generate alert. That means you will have a lot of alerts, right? So some of the users saying, no, I don't want to see that. Can I tune it down, right? So that's one way. The other one is, can I give you feedback? This is not outlier. Do not ever report that again.
Yeah.
Yeah. Yes, we do have that.
I see. Okay.
Yeah.
And how does that translate to, like, someone is saying, I don't want this again. Like, I don't want to see this again at all. How does that translate?
There are different ways to solve that. One thing is, first of all, you have to store the feedback, right? This is what I call it feedback. Could be negative feedback, right? In this case, don't do it again. It's a negative feedback, or this is an anomaly. Next time, do this, right? I have the other side of customer too. So this is for me is to store the feedback, and then I could go from completely unsupervised learning to semi-supervised learning. Right. For the services I don't know, I never monitor, I don't have feedback, probably just use the unsupervised learning. Okay. For the services or applications that the user already give me feedback, so I could start to use more of a supervised learning for that type of customers. Or you use it, yeah, you can also use it as a heuristic, right? You detect this and check the external label and say, hey, don't report this, right?
Okay, thank you. Thanks a lot. Yeah.
I have a comment about what was just being discussed. When I was at Lucent Technologies, also a telecom company, alarm storms were a huge problem because you would see an anomaly, and that anomaly would then result in management action to shut down part of the network to get it fixed, which would then start up another whole series of anomalies, but people would say, oh, this is not working. So I think it's a very challenging problem, and you've described it very well in terms of being a combination of supervised and unsupervised. And at some point, you need a human in the loop to perhaps stop a runaway condition. I think we've all heard of DD, distributed denial of service attacks, right? Which is another type of anomaly that happens. So you don't want to make your reaction worse than the cause. So thank you for your talk tonight.
Yeah, thank you.
So Linda,
yes.
One question that came up in the chat was that if someone wanted to contact you, how would they do that? Would they do that through your LinkedIn?
Yeah, sure. My LinkedIn is same name, Linda Zhou. Let me double check. I think it is. I think so. Yeah.
Probably like Linda Zhou, Cisco probably will.
There are many Linda Zhou, by the way. There are a lot.
Yeah, I'm also hiring.
Oh.
Machine learning engineer.
Bev, do you mind pasting a link in chat so everyone will have that while we're still chatting?
I don't know, Linda, do you have it, or I must be able.
Yeah, can you find it?
I'll try to find it. Okay, hold on.
Yeah, I have a different machine right now. Nothing is logged in. Yeah, if you're looking for a senior machine learning engineer position, I am hiring. So if you look at my talk, the machine learning will be based on the time series, right? So it could be the metric data, log data, events data, and more of a categorical data, right? So it's really fun. And because of a log, so we will have an NLP portion of it to parse logs to give more human readable messages to the users.
Yeah, in one of your slides in the beginning, you mentioned about non-numeric outliers in the non-numeric data. What would be an example for that?
Log files, categorical kind of data. So basically, when time series, like if you have a sensor, right, you detect something, you could be only having high, low. Those kind of data, you have to convert them, right, into numerical data. So it's so you can feed into the algorithm, okay. And the other part of it, if you look at time series data, we always have an agent to collect the data, and we found very, very often your agent may be dead, right? So it's not sending you data, so you will have missing data. Then you have to do a data validation and imputation fill the missing data.
Mhm. Thank you.
Yeah.
I assume you can, a simple heartbeat or an alert would happen to start that, to let somebody know that agent needs to be started again.
Yeah, but I have seen agents out of commission for
really
like
long
10
time.
minutes. So
Yeah, when there's missing data, so you have to
yeah.
interpret that.
Yeah, so basically missing data in my world is completely missing the entry, right? It's not NaN, it's just no entry.
Last call.
Well, I guess in that case, you have the classic problem of, is the person on the other side crazy or dead? You know, crazy playing dead, but they're going to come back, or are they really dead? So.
In my world, it's a machine. So if they are really dead, someone need to restart that agent.
Well, dead as opposed to just being incredibly busy.
Hopefully.
Yeah, so you don't necessarily,
monitoring.
you generally don't want to just kill it on hand. But if it's dead, you want to restart it. So,
yeah.
So.
OOM for the win. Jeff, I see no more.
Great. Well, thanks a lot, Linda, for the great talk.
Thank you.
Thank you so much.
And thanks everyone for coming tonight and spending your time to listen to our talks. Have a great month and stay healthy.
Awesome. Thanks, everyone.
Thank you.
Bye.
Bye.
See you, everyone.